All right, guys, so we just finished the test and now we move on to writing algebraic expressions. Okay, so they're pretty much word problems or, expressions written in sentence form, and we're supposed to convert them into an algebraic expression. And then eventually we're going to go ahead and solve them. In other words, find the answer. For now, we have just expressions. That means we don't have to solve. So let's go ahead and begin. Okay, 8 more than a number. Okay, so remember, notice here they don't tell us what this number is. They just say it's some number. So 8 more than some number is another way to think of it. So how would you write that? Well, 8 more than some number. Let's just pretend that one number or that some number was your age. So let's say 15. Let's say you're 14. Let's say you're 13. It doesn't matter what age you are, right? So let's just pick a number. Let's say, like, for example, 14. So how would I write 8 more than 14? Okay, well, it's more than this number here, so we have to put that number first. So since we don't know if that number is 14, it could be any number. We're just going to use this here, a number, as a variable. So I'll just call it x. You can use any letter of the alphabet. Okay, x is usually the first one that we use. So x, and then 8 more than that. So x plus 8. Okay, that's it. That's our expression. Okay, that's all we have to write. 8 more than a number is the same thing as x plus 8. Okay, next one. 10 times a number. So notice all these will say just a number. So that means we can use a variable. 10 times a number. Okay, so this is saying 10 multiplied by a number. So we could just write 10, and then I'll just use y this time. So 10y. 10 times y. I can put a little dot right there in between them, right in the middle. But really, when we have a coefficient or a number and a variable, we don't really have to use anything in between. Okay, we can use parentheses also, but again, not necessary. What about twice a number? Twice means how many times? It means 2 times. So 2 times a number is another way to read this. Twice a number is the same as saying 2, and then I'll use r this time, so 2r. Again, you can use x all the way through if you want. If you like just using x for all your variables, you can do that too. Okay, so twice a number, we have 2r in this case, 2 times r. What about this one here? 6 less than a number. So it's kind of like the first one we did where we said 8 more than a number. Notice how the number went first. A number, right? And then 8 more than that would be plus 8. So we're adding 8 to this number because it says 8 more than this number here. So in the same way here, we have 6 less than. Less than what? Less than this number here. So we have to go ahead and put that variable. I'll use x again. So 6 less than this number here is going to be x minus 6. Now, it's a little confusing because you see, wait, the 6 came first here. Yes, but remember, it's saying this is 6 less than something. And what's that something? It's less than this number here. Whatever that number is, it's 6 less than that. Okay? 1/5 of a number. 1/5 of a number. Now, if I said 1/2 of a number, like say, for example, I said, what's 1/2 of 10? Or what's half of 10? That's easy. You just cut 10 in half. That's 5, right? But this is saying 1/5 of a number. So instead of dividing it by 2 by saying 1/2, right? 1/2 is 1 over 2. Well, 1/5 means dividing it by 5. So 1/5 of a number, you could think of it as 1/5 times x. I could put a little dot right there and times x. Okay? Or you can say this. So 1/5 of a number is basically, and we did this in the past here, when we have a variable here, we can multiply the numerator and the variable. It'll just be x over 5. So 1/5 of a number really means divided by 5. Kind of like 1/2 of a number means to divide it by 2. Okay? So 1/5 of a number means divided by 5, or you can multiply by 1/5. Okay? Now let's get into, well, we got one more and then we'll get into some longer word problems here. 4 greater than a number. Now we know that greater than, we just did inequalities here. But here we're actually not going to use the inequality. What we're trying to say here is that 4, in other words, 4 more than a number. So more than or greater than, that means the same thing in this case, okay? So what operation is that? Addition, subtraction, multiplication, or division? What would more than or greater than be, right? So yeah, it would mean addition. So again, we have a number, and then we have something that's 4 more than that. So 4 more than a number, which is x plus 4. Okay. All right, take a look at this here. It says Allison is 4 years younger than, we know what that means. She is 4 years younger than her sister Camille. If Camille is C years old, notice they give us a variable here. They don't tell us a number. They don't tell us that she's 15 years old. They don't tell us that she's 20 years old. They just tell us that she's some number. Camille is C years old. How old is Allison? Okay. So what do we know? We know Allison is younger than her sister Camille. So Allison is 4 years younger than Camille. Well, how old is Camille? Camille is C years old. So we're going to take Camille's age, which is C. And what do we do to get Allison's age? Okay. Well, we're going to go ahead and subtract 4. Because Allison is 4 years younger than Camille. So Camille is older. So she's the older sister. And so Allison, to get Allison's age, just subtract 4, and there you have Allison's age. Now we can also do this, watch. Allison's age equals C minus 4. Okay. So A stands for Allison, C stands for Camille, and then minus 4, we do that because she's 4 years younger, and that's how we get Allison's age. If we know Camille's age, we can get Allison's age by subtracting 4. Next one. Ryan bought a movie ticket for X dollars. So we don't know how much he paid. All we know is that he paid some amount. They call it X. He paid with a $20 bill. How much change should Ryan get? Okay, so we know that he bought a movie ticket. That means he spent some of his $20. And we know he spent X dollars. Okay, so how would I write this expression here? He paid with a $20 bill. So we know that he gave a $20 bill to the cashier. And then what did the cashier do with that? He charged him for the movie ticket. So what happens to the $20? Right. It gets some amount subtracted. How much did he subtract? X dollars. So we know he subtracted the movie ticket. X stands for the movie ticket. Okay. So the change, how much change should Ryan get? So we could just say C for change. The change is going to be $20 minus whatever the movie ticket costs. We'll say X. Okay. All right. Next one. Bridget spent $5 more than Tom. So we know Bridget spent more than Tom at the mall. If Tom spent X dollars, how much did Bridget spend? Again, we know that Bridget spent $5 more than who? Than Tom. Well, how much did Tom spend? Did they tell us? If Tom spent X dollars, so here we go. He spent that much. He spent X dollars. Now, we don't know what X stands for. It could be $20, it could be $50, it could be $100. We don't know that. It could be anything at this point. So all we know is that he spent X dollars. But then it says here, Bridget spent 5 more than Tom. So whatever Tom spent, add 5 to that, and that's how much Bridget spent. So we'll use B for her name. So Bridget spent $5 more than Tom. Getting the hang of this? Try this one here. Try this one. Mark has twice as many baseball cards as hockey cards. If Mark has H hockey cards, how many baseball cards does he have? Okay? So try this one on your own. Hit the pause button. And then try writing it out. Then press play to see the answer. Okay? So here we go. Mark has twice as many baseball cards as hockey cards. If Mark has H hockey cards, how many baseball cards does he have? So we know that he has H hockey cards, so H, right? But let's say he had 10 hockey cards, okay? If Mark has 10 hockey cards, we know that Mark has 2 times or twice that many in baseball cards. So whatever he has in hockey, multiply by what to get the number of baseball cards? That's right, multiply by 2. So 2 times H will equal his baseball cards. So the baseball cards is going to be equal to 2 times whatever he has in hockey cards. So if he has 100 hockey cards, how many baseball cards would he have? Well, 2 times 100 would be 200. So that means he would have 200 baseball cards. Again, it says here Mark has twice as many baseball cards as hockey cards. That means he has more baseball cards than hockey cards. How many more? Well, 2 times more. Okay, that was a little hard. Okay, let's move on to the next one. This one's a little easy. I'll let you guys try this one on your own. It says, Elizabeth's ballet class is 45 minutes long. If Elizabeth is M minutes late, how many minutes will she spend in class? Okay, so it's kind of like us in class right here. Our class is about 45 minutes long. If you get here late, right? So how much time will you have left? So again, her class is 45 minutes long. So we know that's the total amount of time of the class length. But if she gets there late, M minutes, what do we do with that time? Do we add it to the 45 or subtract it? That's right. If she's late, that means she's that minutes less in class. And so we know that, let's say if she was 10 minutes late, we would subtract 10 minutes from the 45. She would only have 35 minutes left of class. Okay? So however long she was late, what if she was late 1 minute? Well, then we just subtract 1 minute, and then that means she has 44 minutes left of class. Okay? And so we'll say class is going to be, the class time is going to be 45 minutes minus however many minutes she's late. What if she's 0 minutes late? Well, 45 minus 0, that means she's there the whole time.